Hello everyone, my name is Pravesh and welcome back to my channel. Today I'm going to walk you through how to deploy a highly scalable and highly available Django application on AWS using Terraform for full automation. So by the end of this project, you'll know how to provision AWS infrastructure with Terraform, deploy a Django application in a load balanced and multi-agent setup, and make it fault tolerant and production ready. So let's dive into it. So here's what we are going to build today. We are going to run a Django application on AWS with VPC for networking. We'll have public and private subnet in multiple availability zone to make it highly available. We'll have internet gateway for public access. We'll create an application load balancer to handle the incoming traffic. We'll create an auto scaling group to dynamically add and remove EC2 instance based on the traffic. We'll have an 𝗕𝗃𝗵𝗆 database as our database layer, and at last we'll have security group to lock down access. And the best part is we'll use Terraform to spin all this infrastructure automatically. So before we begin, we need to make sure we have the following prerequisite checked down. So firstly, we'll need an AWS account with an IAM user that have administrative access. So only for the sake of this project, I am recommending you to have administrative access. But in production environment, it is recommended to use the principle of least privileges. And then we need to install AWS CLI on our host machine and configure our IAM user using AWS configure command. And now at last, we need to install Terraform CLI. So once these items are checked on your list, you're all set to start this awesome project. So since we are using the best practices to build this highly scalable and available project, so we won't be storing our Terraform state file locally. We will be using S3 plus DynamoDB combination. So I was browsing through the Terraform docs on AWS backend hosting, and I came to know that the S3 plus DynamoDB combination is deprecated, and Terraform recommend us to use S3 use log file tag for state logging. So I tried that on my system, but due to some reason it didn't work. So I just get back to that S3 plus DynamoDB combination, which is tried and trusted method. So the code of this project is hosted on this GitHub repo. So I want you to just clone it using git clone command. So I have already done that. So I have just opened this project. So here we have the scripts and the Terra config. So firstly, we need to set up the S3 bucket and the DynamoDB table. So instead of creating it manually, I have created a config.sh file that will create the S3 bucket and the DynamoDB table. Now let's use the config.sh file to create the S3 bucket and the DynamoDB table. So let's go to our VS Code. Here inside the script directory, we have the config.sh file. We'll first make it executable using chmod command, and then we'll just run the file. This will create an S3 bucket named Pravesh TF2 bucket, and it will turn on the versioning, and at last it will create a DynamoDB table named Pravesh state table. So if you get any error related to the name, you can change it in the config.sh file. You have to just change the name in the environment variable and it will handle everything. But if you change the name, make sure to update that name in the backend.tf file, because it will be used for configuring our backend for the Terraform state file. So our backend is configured. So now we need to create our secrets for the RDS credential. So instead of putting a credential in the Terraform code, we'll create a secret manager and for our RDS table. So just use this command, copy it. I have also provided the command in the commands.md file. So you can just simply copy it and run it. I have already done that, so I'm not going to use it again. So firstly, we'll create the credential. The username is admin and the password is admin1234. Then we are creating a policy for our IAM user, because our IAM user will be interacting with the secrets manager, so it needs to have access for that. So we are just attaching two permission, which is get secret value and the describe secret. Here you need to change your account ID here before running the command. So you can find your account ID by going to your console. So here, this is my account ID. So similarly, you can get yours. So you can run this command, and after that you just need to attach your policy. So go with this command and paste it inside your terminal. So make sure you change your username here, like my IAM username is light, so you need to change it accordingly, and similarly you need to change the account ID here. So this will attach the policy and create the RDS credential. So once that is done, you are done with the prerequisite. So now let's navigate inside the Terra config directory, which will contain all the Terraform related code. So here you can see that we have application load balancer.tf file, provider, outputs, IAM, and many more. So let's go through it one by one. So firstly, we have our provider.tf file. It is basically specifying that we are using AWS as a provider, and we are setting as region as in a variable, which is AWS region. So let's go to the variable.tf file. So we are specifying our AWS region as US East 1. The project name is employee management. We are specifying the 𝗵𝗶𝗴 CIDR range as 10.0.0.16. And similarly, we are setting the public subnet CIDR and the private subnet CIDR. And at last, we are specifying the instance type for our auto-scaling group as T3 micro. So these are basically a bunch of variables. Instead of storing value hard coding, we are just creating variable of that. So after that, we have our data.tf file. So firstly, we are getting the availability zone for our application load balancer. So we are using the state as available to get the available zone. Next, we are getting the Ubuntu AMI ID using the data AWS AMI command. So here we are specifying that we need an AMD Ubuntu latest image. So I forgot to change this name to Ubuntu. Earlier I was trying it with Amazon Linux, but something was not fine. So at last, we are using AWS Secret Manager to get the secrets for our RDS credential, which we recently created. Okay. And at last, we are using this environment, setting up this environment variable in our user data. So we have a user data.tpl file, which will use this environment variable, and it will help our EC2 instance to get this user data and run our Django application, because our Django application needs some environment variable to run. So which means we need to set our database name, the user, and the password, which is admin and admin 1.1234 as the password. We are specifying the port as 3306, which is default MySQL post, and we are getting the host as the RDS instance endpoint. Okay, so let me show you the user data.tpl file so that things make sense to you. So just like user data.sh file, user data.tpl file is specifically for Terraform. So it helps us to use Terraform variable in it. So imagine this, it is just like a shell script. So firstly, we are using shebang, which is a prerequisite for any bash file. Then we are setting up, we are updating the system, we are installing some packages. And then here is the interesting thing. Here we are providing the environment variable from our TPL file, from the locals variable. So these are just for logging, because I was getting many errors, so I just put this for logs. And then we are creating the database, which is our 𝗵𝗶𝗴𝗵𝗆, I guess. Yeah. So we are creating a database with the name 𝗵𝗶𝗵𝗵, and here we are cloning the Git project and navigating inside it. We are creating a virtual environment, activating the virtual environment, and installing the required dependency. Then we are changing the ownership because there was some permission denied error while I was exploring. Then we are giving a 1 to 10 second random type to sleep, so that the server should process everything. And at last, we are using Python 3 manage py.migrate command to migrate our database from MySQL local of Django to our RDS instance. And at last, we are just starting our application at port 8000. So this is the user TPL file. In the 𝗵𝗶𝗴𝗵𝗆 file, we are creating a VPC named our employee management, which is our project name. So we have specified all the private subnet and the public subnet CIDR in the variable. We are enabling that we need a NAT gateway, we need DNS host name and the DNS support. And at last, we are just providing that name this VPC as our project name, which is employee management. So then we have our ESG launch template. So it is for our autoscaling group. So here we are specifying the launch template. We are providing the AMI ID, which is our Ubuntu AMI ID, instance type as 𝗕𝗏 defined in our variable. So we are attaching the instance profile. So let me just show you the instance profile first. So let's go to im.tf file. So our EC2 instance, which will run in the autoscaling group, we need some way to access them. So instead of providing a key pair, we are using SSM client to connect to the instance. So we are firstly creating a role which allow STS access, and then we are attaching a policy named SSM managed instance codes. So it is a prerequisite for that role. And at last, we are attaching this role to an instance profile, and this instance profile will be added to the autoscaling group. So like this instance profile is attached to this, like the profile name. So we are defining it there. So it allows us to access the EC2 instance using SSM client. And in the network interface, we are defining our security groups. I'll show you that later. So we are not providing any public IP address, so that our auto load balancer is the only way so that user can have access to our application. So next we are specifying the autoscaling group. So here we are specifying how many instances we need and what is the minimum and maximum capacity. So like we are naming it from the project employee management -𝗏. We are defining maximum size as 1, minimum size as 1, and desired size as 1, so that we don't encounter any cost issue. So in production environment, you can make it bigger according to your user base. So here we are specifying our private subnet and the launch template. So here next we are specifying our AWS load balancer target group. So that's it. So after that, we have our application load balancer. So here we are specifying the basic load balancer configuration and providing our subnets, security group, and load balancer type is application, which means it's an application load balancer. And then we are defining a target group. So our application will be running on port 8000. So these are some health checks and the condition for health check, and VPC ID is provided. And here we are just providing our AWS load balancer listener. So this will listen and direct our action to the target group of our application load balancer. So now let's go to RDS and see how things work here. So firstly, we are creating a subnet group in RDS. So if you have experimented with RDS, you know that we need to create a subnet group to work with RDS. So we are creating a subnet group named employee management RDS subnet group. So we are giving the subnet ID as for our private subnets and giving it a name. And at last, we are creating an DB instance, which is 𝗵𝗏. The engine version as 8.0. The instance class as db.pre-requisites. So instead of providing our password here, we are using AWS Secret Manager, and in this way we are just securing our application and not hard coding our password here. So it is multi-agent, which means it is highly available. We are skipping the final snapshot and because we don't need it, and we are disabling the public accessible so that only the load balancer can access it. So after that, we have our outputs.tf file. So if all the configuration is completed, we will be given the DNS name. It will be the address on which our application will be running, and the RDS endpoint, so to test what is the host name of the database. Okay, so at last we are having our backend.tf file. So this generally specifies that we are hosting our Terraform state file on S3 bucket plus DynamoDB combination. We are providing our bucket name here and the DynamoDB table name here. So if you have given a different name, you need to update it in the backend.tf file. So that's the explanation of the Terraform configuration. Now let's apply it and see it work. So let's firstly initialize the Terraform directory. So make sure you are in the terraconfig directory of this application and just run Terraform init. So our Terraform is initialized successful. So let's see what are the resources that would be created using Terraform plan. So about like 41 resources will be created. So there is an error here. Let's fix it up. Ubuntu. Like I think I changed the name and it's not working fine. So let me just do that. It was Amazon, right? So let's run it again. See if things change. Okay, perfect. So now we are seeing that 43 resources will be created. So these are like a small description of it. So you can go through it. So now let's run Terraform apply command. Before running that, like I forgot to explain you the security group.df file. So here we are creating 3 security group. One is for application load balancer, one is for our front-end application, and the last one is for database layer. So the application load balancer security group will have 3 rules, two of which are ingress, which is on port 80, that is HTTP, and the other one is on port 443, which is HTTPS. And at last we are specifying that all the egress traffic will be allowed. Similarly, in the application security group, we are specifying that port 8000 will be available for any traffic that is coming from application load balancer, not from everywhere. And in the egress, similar, we are specifying everything outside. And at last, the RDS security group, we are specifying that any traffic coming from application security group will be allowed on port 3306, and egress traffic will be allowed as usual, which is for everyone. So now let's apply the Terraform file. So it will take about 10 to 15 minutes. So once it is done, I'll get back to you and we'll see the application running on the DNS name. So let's do it. So the resource creation has been started. You can grab a cup of coffee in the meantime. So I'll meet you after 10 to 15. After like 10 to 15 minutes, our infrastructure is up and running. I would advise you to give it 2 or 3 more minutes so that the instance get in healthy state. Also in the meantime, I have also changed the desired capacity to 2 so that I can show you how the high availability things work. So let's go to the DNS address, and in theory, the application should be running on this address. So let's do it. So let's paste it here, and voila, you can see that our application up and running. So let's add an employee. 𝗵𝗶𝗴𝗵𝗆 is a DevOps engineer. Add the employee. So you can see the data. So let's just again run it, and if the data persists, which means it is stored in the database. So you can see that here we have our entry. Right? So let's see in console how things are working under the hood. So let's go to EC2 and see the instances. So we have 2 instances running, and here we have our load balancer, which is active state, and it has this target group. So you can see that we have total 2 targets, and all the 2 are in healthy state, which means that if I terminate one of the instance, it will route traffic to another healthy instance. So you can see how application load balancer automatically route traffic to the healthy instance. So let's do it. Let's go to EC2 and terminate one of the instance. So terminate. Let's do it. Now let's access the application. So you can see that the application is still running. It has no impact because the traffic is routed to the different instance. Okay, and you'll see a new instance will be up and running soon. Okay, so let's also see RDS. Here we have our database. So you can see that It has some slight downtime. I don't know why. So I added the same employee again, I guess. So it is taking some time. So let's refresh it. Here you can see that one is in healthy state. It is taking some time. So you can see that our data is being persisted here. So that's it. We have successfully deployed a highly scalable, highly available Django application on AWS with Terraform, fully automated, scalable, and production. Before concluding, we need to tear down our resources so that we don't incur unnecessary charges. So firstly, we'll destroy all the resources that we created through Terraform, and at last we'll use the delete.sh script to delete the S3 bucket and the DynamoDB table. So after trying out the project, just run terraform destroy 𝗬𝗏 command. It should be in the terraconfig directory. So let's do it. So it will take about 5 to 10 minutes to delete all the resources. So once it is done, then we can move forward and delete our S3 bucket and the DynamoDB table. So let's give it the time. The Terraform resources are destroyed successfully. Now let's remove the S3 bucket and the DynamoDB table. So firstly, we'll navigate back to scripts directory and we'll make the delete script executable. Okay, so let's just check the name of it. We have specified the correct bucket name and the table name. So let's just run it. So this will delete the S3 bucket and the DynamoDB table. Okay, so both of them are deleted successfully, and this ends the project. If you found this useful, don't forget to like, share, subscribe, and turn on the bell notification for more DevOps and AWS related content. I'll see you in the next one. Till then, ciao.